Okay, so for part 2, I'm actually going to use the NPV formula in Excel, and I'm going to use the same question but change things a little bit. So if you want to pause and actually see the facts, they are there now. All right, so we can use what we started doing here, map out the cash flows. We have the initial investment is 3.5 million, and I'm just writing that in as 3.5 to make it easier to work with. And the facts here, we get, this is 1 million. I'm going to take that out. We get 1 million every year for the next 5 years. I looked up the rate and it's 10%. That was not in the question, but I found it, so we can use it here. And the period is 5 years. Okay, so now I want to actually map it out a little further. So column for the years, column for the cash flows. So zero through 5, and again that first capital outlay is 3.5 and it's an outflow, so I made it negative. And then for the next 5 years, we're going to get 1 million every year. Okay, it's really important to note that the NPV formula is in Excel. However, you do have to add something to it because it does not calculate it the way we do in accounting. So you want to do equals, and then the first thing you're going to do is point to the cell that you have that initial capital outlay in. And that ends up getting added to what it calculates here with the NPV. The first thing is the rate. We wrote that up there, so we'll point to that cell, comma, and then it wants the values of the cash flows that are coming in each year. So that's all of these. Highlight those, close your parentheses, and boom. So that is it. And again, we shorten the numbers up here, so this is really that 291,000 that we saw as the answer here in C, accept the proposal, because the NPV is 291,000. So that, again, that rounded. So it's important to understand what you're really doing here and what the methodology is behind this. But that NPV formula, this method would still work if these were different. So if you only got $500,000 back in year 2 instead of that, then calculating that NPV down there, and now it's negative, so you would not want to accept this. So what this is really doing is taking the present value of each of these lines, and I've done practice questions where they gave you the present value factor, so you were really just multiplying the factor they give you by the cash flow for each year and then netting them together. But I don't know, you could possibly get one that does this. So it's as simple as using the present value formula, point to the rate cell, point to the period, there's no payment, future value, right there, close that, and there you go. And that's a great way to check if you did the formula correctly, is if these are equal to each other, because again, you're in year 0, so this amount now should equal itself. And if you add dollar signs in around that cell, then that'll lock that in. And here you also want to make the future value in the PV formula a negative, because that's just how it works. So this ends up coming out negative, and then you can just drag that down and it copies that same formula, and now you have the present value of each of these amounts for each year, and then you just need the sum. So you can see you get the same answer. That was obviously longer, but it's good to know what's actually happening in the problem, and if they just give you the factors and you do have to multiply each line by line, then that really shows you what you're actually doing.